You know that feeling, right? You're staring at a massive spreadsheet, trying to make sense of it all, and it just feels like you're wrestling with the data instead of analyzing it. Well, you are not alone. Today, we're going to talk about a tool called Pandas. It's often called Excel on steroids, and believe me, it can totally change the way you work with data. Let's get into it.
So if you ever ask a data scientist what they actually do all day, you'll probably hear them mention the 80-20 rule. And you might think, oh, they must spend all their time building these super smart predictive models. But the reality is a little less glamorous.
Yeah, you heard that right. A whopping 80% of their time is just spent cleaning and preparing data. See, raw data is almost always a mess. It's got missing values, it's got typos, different formats. It's just chaotic. And trying to fix all that in a normal spreadsheet, it's a painfully slow manual process of clicking, dragging, and writing formulas that barely work. It's a total productivity killer.
But what if you could just automate all of that cleanup? What if there was a tool that was not only way faster, but also made your entire analysis something you could repeat perfectly every single time?
Well, that tool actually exists, and its name is Pandas. It's basically the industry standard Swiss Army knife for handling data in Python. It lets you clean, filter, and analyze huge datasets using code.
Now, the absolute heart of Pandas is this thing called a data frame. The easiest way to think about it is like a spreadsheet, but a programmable, supercharged one. It looks like an Excel sheet, with rows and columns, but it lives in your computer's memory, which makes it incredibly fast. And it comes with some serious superpowers.
And this right here, this visualizes the huge leap we're talking about. You're moving from a static, manual task to a dynamic, software-driven process. You stop being just a viewer of data, and you become a creator, someone who can shape and transform it with code. It's a total game changer.
So what are these superpowers? Well, first, you get to access data with intuitive names, like age, instead of trying to remember what's in column G. Second, it is insanely fast. Thanks to something called vectorization, you can apply an operation to an entire column all at once. And third, programmability. Everything you do is code, which means your whole analysis is just a script that you or anyone else can run again perfectly.
Okay, all this theory sounds great, right? But let's actually see it in action. To really put Pandas through its paces, we're going to use one of the most famous datasets out there, the passenger list from the Titanic. It's the perfect example of real-world, messy data.
And right off the bat, we hit two very common problems. A whole bunch of passengers don't have an age listed, and even more are missing a cabin number. Now, in a spreadsheet, you'd be stuck manually deleting rows or trying to fill in the gaps one by one. But with Pandas, we can be much smarter about it.
And this is where it gets really cool, because Pandas lets us be surgical. We have two different problems, so we're going to use two different strategies. For the cabin column, most of the data is gone, so it's not really helping us. With one single line of code, we can just drop the whole column. Boom, gone. But for age, if we dropped those rows, we'd lose tons of valuable info. So instead, we use a clever technique called imputation. We just calculate the median age of everyone on the ship and use that number to fill in the blanks. Two tricky problems, solved in seconds with code.
All right, so now our data is clean and tidy. The grunt work is done. This is where the fun really starts. We can finally stop being data janitors and start being data detectives, looking for the stories that are hidden inside all those numbers.
Which brings us to a classic, haunting question about the Titanic disaster. We've all heard the phrase, women and children first, but was social class a hidden factor? In other words, did you have a better chance of surviving if you were rich? Answering this question in Pandas is just, well, it's beautiful. We use this powerful method called split, apply, combine. First, we tell Pandas to split the passengers into 3 groups based on their ticket class, first, second, and third. Then, we apply a simple calculation to each group. Find the average survival rate. And finally, Pandas combines those results into a neat little table for us. It's an incredibly powerful way to compare different groups.
And the result is pretty stark. The data shows that yes, socioeconomic status was a huge factor in who survived. First-class passengers had a much higher survival rate than those in third class. With just a few lines of code, we've uncovered a powerful and uncomfortable truth hidden in the data.
And that whole process really gets to the core of why this approach is so much better than just clicking around in a spreadsheet. It's all about why. For any serious data work, code will always beat clicks.
Let's just break it down.
First, reproducibility. In Excel, your analysis is just a memory of clicks. It's impossible for someone to perfectly replicate. With Pandas, you have a script you can share. Second, speed. Excel will start to choke and crash with 100,000 rows. Pandas can handle millions, no problem. And finally, automation. A boring, repetitive task in Excel is always going to be a boring, repetitive task. In Pandas, you can turn that task into a fully automated pipeline. It's not even a fair fight.
And honestly, if you take one thing away from this, let it be this. When your analysis is code, it's not just a result, it's a recipe. Anyone, including you, 6 months from now, can run that same script and get the exact same result. That is the foundation of reliable, trustworthy data science.
So you see, Pandas isn't just a slightly faster version of Excel. It's a completely different way of thinking. It transforms your entire workflow from a series of one-off manual chores into a repeatable, scalable, and transparent science.
At the end of the day, every single data set has a story it's trying to tell. But if you're spending 80% of your time just trying to smooth out the pages, you're never actually going to get to read the story. So the real question is, are you using the right tool to actually hear what your data has to say?